Welcome to ClickMyProject.com. Our project title is a soft switching double input microinverter. Project abstract is this inverter is based on forward resonant inverter and then two series boost converter. The boost converter is the boosting of voltage. That is the coupled electrical and then applies 5 switches totally. The input power or control this separately for duty cycles of the input switches. So one of the input is omitted and the operation of inverter is not intercepted. So the energy is transmitted to the output and then provide the soft switching conditions. The secondary side switches are the control at a low frequency to the control the directions of current in each half cycles of the output voltage. The proposed inverter is analyzed and then design consider of soft switching range is discussed. This simulation control is present on duty cycle base and then soft switching. Our project flow diagram explanation. First of all is the solar panel. Solar panel is the one of the input of source. Is using for the input in the irradiation and temperature. Irradiation is the 1000 or 1200 is values will be check the step levels and then temperature. Temperature 25 degrees Celsius or 32 degrees Celsius it will be set. The solar panel input of irradiation temperature is the output of transfer the data transfer to the fly capacitor. The flying capacitor is the charging of the capacitor is the charging and discharging of batteries. After that DC to DC DC to AC multi-level inverters. The multi-level inverters are using the inverter of switching pulses. The switching pulses is the PWM pulse. The PWM is the pulse width modulation. Pulse width modulation is the S1, S2, S3 and S4, S5, S6. These 6 switches are used. Three leg of inverters. The first and the S1 and S2 are the T on and T off condition. After that S4 and S5 is the T on and T off condition and S5 S6 is the T on and T off the condition. So overall generated the three sine wave, one shortwave wave, the pulse will be generated. The pulse generated is the duty of the pulse through to the DC to DC, DC to AC multi-level inverters of input. So finally is connected to the AC of grid. The grid is the micro grid or any other AC grid. The overall flying capacitor using for the AC grid. The AC grid is a storage of battery and then ultra capacitor. Everything is storage of main grid. Is a supply to the transfer of anything, so the electric vehicles or else supply the AC grid wise. Our project explanation. First of all is the PV model. This is a PV model of array. So for parallel of string 4 and series of connected in 2. The plot of 1 kilowatts of solar panel. This is the 1 kilowatts of solar panel. This is the module of solar panel. Is the maximum power 120 watt and then open circuit and then voltage, maximum power point and temperature. First of all, the input of solar panel is irradiation and temperature. Irradiation level is 1000 and then temperature level is 25. Okay. After that is the MPPT based on PNO. The MPPT based on PNO is the input of voltage and current. Input of voltage and current. Finally is calculate the duty cycle. Okay. As the duty cycle will be calculated, the scope of duty cycle, and then This is the switches of MOSFET, and then diode. This is a diode. This is a gate pulse through to the pulse width modulation. The pulse width modulation is the three sine wave, one short tooth wave will be connected. Is connected with the NOT gate of condition greater than or equal to 0. Uh, and then gate supply is the S1, S2, S3 and S4 of pulses through to the MOSFET of switches. The MOSFET of switches is a three parameters. One is a drain source. After that, connected to the AC voltage, AC grid, AC voltage of source. Finally, is the how much of current and voltage will be calculated. The discrete mode wise generated the simulating model. The time set of 0.2 seconds. The compiling is ongoing. The completion is overall run. So the finally output is the voltage and current.